Hello to all. Good afternoon. We are going to start the keynote from 𝗖𝗁𝗂𝗀𝗁𝗍 with Professor Evner that has already joined us. You can see him in the top corner there, in the shade. Welcome, Professor. Good afternoon. How are you?
Thank you. Doing well. Glad to be part of this great conference. So I'll let you get us started.
Okay, Professor. Without further delay, Professor Alan Evner is a distinguished university professor and eminent scholar in the School of Information Systems and Management, the 𝗜𝗏 College of Business at the University of South Florida, United States of America. He holds the Citigroup Hidden River Chair of Distributed Technology. Also, Dr. Evner, areas of research and interest include design science research. I know that we all know him from this particular area. We and probably thousands and thousands of scientists across the world. He also works within information systems development, so software engineering, distributed database systems, healthcare systems, Internet of Things computing, which is something that is critical nowadays. He has published over 300 research papers on these topics and has consulted for a number of Fortune 500 companies. And I also would like to add that he received his PhD in computer science from Purdue University, USA. He has had faculty positions at University of Maryland and University of Minnesota. Also a fellow of the American Association for Advanced Science, a fellow of the Association for Information Systems. This is a very well-known IES association. And of course, he couldn't miss the IEEE, which is the premium, would say, college for engineers across the globe. He's also a member of the ACM and Informs. Additional honors include the selection of Parmas Fellow at LIRO, the Irish Software Research Center, a Scholar Senior Fellow at Friedrich Alexander University in Germany, and in 2018 distinguished with Alumnus Award from the Purdue University in Computer Sciences Department. From 2006 to 2009, he served as a program manager at the U.S. National Science Foundation, in the Computer and Information Science and Engineering, where he holds the directorate. So, Professor, I will put you on the large screen here. I will ask you to share your own screen. And thank you for being at 𝗖𝗁𝗂𝗀𝗁𝗍. For us, it's very important to receive such a distinguished keynote speaker. Hence our motto, of course, fits very well your research area where you have taken broad steps toward the science field. And our motto is to join what computer sciences has and can offer for industry science within the innovation token. Thank you for being here, Professor. The stage is yours.
Very good. Well, thank you for that fabulous introduction. It's a pleasure to keynote this conference. And I wish I were there in Porto. I did have the opportunity to spend some time in Porto at the European Conference of Information Systems in 2017, which was in 𝗜𝗏𝗂𝗁𝗂𝗀𝗓. So it's a beautiful place, and I hope to get back there very soon. So yes, let me share my slides and give you the opportunity to work with me through this set of slides. You know, as we work through this, I know there are a lot of ideas that I'm going to share. In fact, I'll probably provide more questions than answers to your group here. So you'll see my email. I'm very happy to share and respond to questions. Okay, let me see. There, I think you can see my slides at this point.
Indeed, Professor.
Okay, excellent. Okay, well, let me go ahead and get started. As we go through, if you do have questions, I'm happy to stop and discuss those questions with you. And you'll see a number of references as I go through these slides. So if you would like copies of these slides, I think both the chairs have copies to share with you, and I'd be happy to share some of the references that you see here also. So let me start by just challenging everybody with, I think, one of the outstanding quotes from Teddy Roosevelt a number of years ago, that it's the person who's in the arena, who is doing the work, doing the blood, sweat, and tears that is important. And that's how I view design science research. You know, we're actually working with the practitioners, we're daring greatly, we fail often, but hopefully we fail fast and learn from those failures. So daring to do good design science research, I think is an audacious venture. You know, it's hard to achieve optimal, repeatable results, and it's hard to rely on, at times, on existing theory because often they do not produce predictable results. So as we do this research, I think we're looking for these rapid cycles of build and evaluate, where we continuously produce emergent and satisfactory results. And we get the feedback from practice that tells us when we're moving toward good results. And even when we do get a good result, we're often faced with rapid changes in our problem and our solutions. So we're facing some difficult challenges, and I want to just briefly overview those type of challenges in this presentation. But I think doing good design science research, it's fun, it's satisfying, and we are in the arena, and we do change the world. So let me start with just a small set of slides to recap, to bring people up to understanding of, you know, where we want to engage our practitioners. There's a number of stakeholders here that we want to involve in this type of research. Users, clients, sponsors, practitioners. And our projects are typically team-based, longitudinal, and goal-driven. So a little bit of background. I mean, design has been with us since the beginning of time. And many, if you will, practical sciences are really focused on good design results. And the roles of creativity, collaboration are very important here. This was brought together in the 70s and 80s by Herbert Simon, who wrote, I think, a seminal text in the Sciences of the Artificial, where he talked about design as a problem-solving paradigm based upon the philosophy of pragmatism. So these are, if you will, the three seminal papers that I've had the pleasure of being part of, and have sort of established what we mean by design science, not only in the field of information systems and computer science, but really across almost all disciplines. I've presented this research to accounting, to different fields of engineering, anthropology, education, and they all resonate with this idea that we need to be creative. We need to design new artifacts and then evaluate them appropriately to solve problems. The big picture is, you know, we're all of us as researchers face this interaction, this tension between new technology and scientific understanding. And so this diagram is a brief showing of that type of cycle interaction. Technology, very rapid, marked by continuous improvement and driven by human and economic utility. Whereas science is slower, it's marked by paradigmatic shifts. And, you know, the scientific process of evaluation, empirical evidence, and hypothesis testing interacts with this new technology. But it's challenging to play the role that is in that interaction. So just a couple slides from the seminal papers. This was, if you will, one of the basic diagrams of what we mean by design science research. It was in the 2004 paper, where we draw our relevance and our problem space from our real-world application environments. We draw our rigor from the existing knowledge bases of theory, foundation, methods, and we as researchers are in the middle there. We do rapid cycles of build and evaluate until we're ready to make two types of contribution. And the contributions, as you see, are the solution back into the problem space to see if we've achieved the goals we set, and then the new knowledge, the new understanding that we have of how we built, how we evaluated, and how we intervened with these artifacts in the problem space. And we add this new knowledge into the knowledge base. And so as we look at design science projects, the 2004 paper proposed a set of guidelines to say, how do you know you're doing good design science research? And so without going through these guidelines in detail, what is your artifact? How is your research relevant? How have you rigorously evaluated the effectiveness, the qualities of that artifact? What are your research contributions? How did you rigorously develop those contributions? How did you search for the best design to actually implement? And there's a challenge here because there could be many, many feasible designs, but how did you rank? How did you decide which design meets the goals of your project most effectively? And finally, how did you communicate this research to the multiple stakeholders? Moving quickly to the 2013 paper that I did with Shirley Greger, there was some question about how is the artifact knowledge? And here we divided that into sort of three levels. First, the actual implementation of the artifact could be knowledge if it hasn't appeared before. But most likely our contributions to knowledge are at level 2, where we build a solution, but then we reflect on its application, its intervention, and we grow, if you will, nascent design theory in the form of constructs, methods, models, principles, rules, so that we can generalize and share the information from our project with the community and let them build upon what we have developed here. And finally, at the top level, level 3, that's where we build fairly well-established, well-developed mid-range theory. It's still prescriptive theory in that it's how we use ideas in the world, okay? And then we developed this 2x2 contribution framework to say, based upon the maturity of your problem space, which is on the x-axis, and the maturity of your solution space, then we are in one of the 4 quadrants. If it's a brand new problem, no solutions available, then we're inventing. If it's a problem space where we have some understanding, but there are no good solutions, then we're improving. We're in the improvement space. If it's a brand new problem, but we can adapt, or the term that we use is exapt, solutions from other problem spaces, then we're in the exaptation. So it's a new problem, but there may be some solutions that we can adapt from other problem spaces. And finally, if we understand the problem, we understand solutions, routine design, professional consulting, a lot of opportunity to make great contributions here, but they may not be research contributions. So typically these 2 spaces, improvement and exaptation, are where we live as researchers. It's great to play in the invention space, but it's rare that we do. So that's the quick overview I wanted to give you in about, 10 minutes here. Any questions? Anybody want to sort of cover any ideas here?
I don't think so, Professor.
Okay, if not, let me move to sort of the meat of the presentation, and that is I want to go over some challenges with you as researchers. You know, how do we really meet some of the important challenges we face as we do good research? And the first one is complexity, because we deal with real world environments, wicked problems as they've been defined in many areas of research. We know that complex systems are diverse, interdependent, connected, adaptive. In fact, a recent paper in MISQ, one of our top journals, basically said the essence of information systems research is the development of complex socio-technical systems. So it's not only the technology, but it's the human interaction with that technology that is critical as we look at these complex systems. Now, how do we try to capture that complexity so that we are solving a real problem here? Well, I would sort of posit that we need to understand the context, the domain, the stakeholders, the time, space, but also it's just as important we understand what the goals of our research are. How do we define goodness and improvement in the problem that we're looking at? So we need to set goals. We need to understand how to measure those goals. And finally, we need to understand we're on, if you will, a dancing landscape. People who work in chaos theory and complexity theory talk about the problem space moving, the solution space moving, so we're always in a world of emergent behavior, self-organization, and change. So people recognize that the problem space is a challenge. In fact, 𝗜𝗦𝗖𝗦𝗜 has dealt with this. Other researchers have stated understanding the problem is 90% of the solution, if you will. And appreciating that we do deal with a dancing landscape is important. In fact, when people talk about repeatability in science, I question that. I mean, what does repeatability mean in design science when the problem space is changing and the solution space is continuously changing? So let me just quickly point to a paper that it's sort of a research in progress idea of how do we establish goals for our research projects, and how do we appropriately bound and scope the projects that we're doing. These are the type of questions that I think we need to ask ourselves, but let me just jump to a potential solution. And my colleagues and I have thought about sort of adapting Maslow's hierarchy to say, as we think through our goals of our solution, we start with the basis of, does it work? Is it useful? So we have a set of usefulness goals. Then we have to think about safety, security, privacy, usability, human interaction, communication, aesthetic, rational behavior, cognitive goals, and finally, as researchers, what's new, what's exciting, what's interesting about our project. And as we try to think about how do we measure those goals, research over the time has identified these type of criteria, evaluation criteria. Some of them measurable, some of them might be difficult to measure, but I think it's important as we understand complexity and how we bound our research that we do define a set of goals that we want to try to demonstrate improvement in as we do our design research. So that's sort of some pointers toward the idea of dealing with this idea of complexity and understanding the problem space that we address in our research projects. So let me move to the next challenge, and that's almost the essence of design, and that's creativity. The essence of design is enabling and harnessing human creativity so that we can engage and promote human progress in the form of products, services, ideas, markets to improve the human condition here. This is a model that I have found useful. It appeared a couple of years ago in a conference on sort of neuro-IS research. But it shows how the external problem space can be mapped into our internal cognitive capabilities of complexity, creativity, collaboration, and control. So external to internal problem space to solution space. So we need to understand the problem. We need to share our mental model of that problem among our research team. We need to be creative to come up with new solutions, new design candidates that we then want to evaluate, refine, internally, and then release and apply, intervene with these creative new ideas into the field, into the actual problem space, do evaluations. So it's sort of a nice picture of how the external world interacts with our internal creative capabilities here. So more recently, in the European Journal of IS, with some colleagues from Europe, we wrote up some ideas of what are the cognitive challenges in design. And so, again, without reading these questions in detail, you can see the type of thinking that a good research team needs to do as they apply their creative and collaborative processes to interesting design questions. So what do we mean by satisfactory solutions? How do we design processes to enable our creativity? And understanding that not everybody's going to come up with the same solution. So how do we approach design problems differently? And how do we address issues such as trust, diversity, personality into collaborative performance? All very interesting questions and challenges. And the final challenge in this area that I want to present to you is, how do we do, if you will, value-based design? How do we bring human values into our design thinking and our design activities? Well, with some colleagues, I've actually, looked at some, if you will, very creative people's design notebooks where they actually reflect on how they introduce value into their designs. And the two examples you see here, if you've ever been to St. Petersburg, Florida, this is the new Dalí Museum that was designed and built about 10 years ago now. The designer, we were able to look at some of his books and how he brought his design values into this structure. The second is a master printer who was actually one of the printers for the avant-garde artists in New York City in the 60s. And he became also an artist in his own right. He's since passed away, but again, I was able to look at some of the notebooks that he created to say, how did he bring his values into his art? So, but I think we're seeing some very important discussions of ethical behaviors, values in our designs, and I think it's very important research for us to do.
Mas na sala acabou?
Yeah, please put it.
Mais tarde foi isso? Meia hora mais tarde, deixa de saber isto.
Okay, I'm sorry, I didn't understand the question.
I think it's not the question. Maybe someone is with the sound on and...
Okay, I'm sorry. So I'll move on, but if there are any questions, please feel free to jump in. Okay, so my third challenge is evaluation, and how do we build confidence and trust into our designs? It's clear that design is an evidence-based science. We have to do our rigorous evaluations in a way that we can demonstrate convincing evidence based upon both the rigor of our evaluations and the evidence, the data that is produced by our evaluations. Evaluation connects the problem space with the solution space. And in some of the research that I've done, we've identified basically two key types of what we term summative evaluation. As we put the artifact into the problem space and evaluate it, we would either evaluate fitness for use. Does it work? Does it satisfy the current existing goals of the application? But also it's important for us to evaluate sustainability or fitness for evolution. Is it built in a way that it will adapt itself to that changing problem environment? Or is it a one-time solution? So the essence of evaluating for evolution is a challenging question here. Now, as we do our evaluation, both for fitness and evolution, we have a toolbox, and it sort of depends on how you were trained as a researcher as to what you are skilled in terms of doing evaluation. You'd like to say, hey, I have the flexibility to adapt my evaluation to the problem space I'm working in. I mean, do I have enough control to say do controlled experimentation? Or am I pretty much observational, doing case studies, field studies? So having these tools in your toolbox and then deciding what is the best way to provide that convincing evidence that is going to result in stakeholder confidence in my solution. So as I talk to doctoral students and people who are being trained on these evaluation techniques, this is sort of the algorithm or the approach that I say you should use. You want to match your evaluation methods to the research question, your goals. If you're drawing from theory, your hypotheses, your dependent variables. Very importantly, your application context. What is the availability of the data, whether it's qualitative, quantitative, primary, secondary. What research skills your team has, what tools you have. And recognizing that as you do your rapid cycles of build and evaluate in the lab, if you will, that's termed formative evaluation. You're forming the artifact, the design solution. There may be a different set of evaluations done in the lab versus in the context, in the actual real-world intervention. So keep all these in mind, and it's challenging to get this right as a research team. And finally, I mentioned this idea of fitness for sustainability. A colleague here at USF, Grandin Gill and myself, did a paper a couple of years ago, a little bit of a philosophical paper on this idea of how could we draw from the thinking in both biology and economics to say, you know, could we look at a design as a sort of a DNA sequence and sort of evaluate its ability to survive, reproduce, and evolve over time. It's sort of an interesting thought, but you know, it's what we need to think about it as good researchers. Let me move to this idea of control, and that is how do we as a research team appropriately apply a good research process, and how do we keep that under control? Now, over time, a number of proposals have been raised in our field, 𝗜𝗏𝗔𝗓, 𝗏𝗏𝗧𝗏𝗏𝗏, and then more recently, the idea of adapting good design research into action research and integrating the synergy between those two. And Sen et al. Made a nice proposal of how to do design in collaboration with your practitioners as part of an action design research. More recently, a colleague again here at USF, Matt Malarkey, and I thought about that a little bit as we applied our thinking into several research projects here. And we came up with what we termed an elaborated action design research process model, where you're at, say, 4 different possible stages. Either you're diagnosing the problem and understanding and designing your model of the problem space. You're designing new creative solutions for your challenge, your research project. You're implementing a solution and intervening with that solution, or you're evolving an existing solution. So you can enter this process at different points, but the important thing is that each of the cycles, whether you're doing diagnosis, design, implementation, or evolution, your cycle of research is similar in that you define your goals for that particular cycle, you create an artifact, whether it's a problem space artifact, a solution artifact, an implementation artifact. You know, there are all those levels of artifact that you are designing and creating, and then evaluating that artifact, reflecting on your evaluations, on its use in a real-world environment, and then learning from that and generalizing, if you will, nascent design theory from your experience in that cycle. So we've also included some principles. A lot of these principles were in the original Sen et al. ADR paper, but we added a couple in our new thinking also. So going back to this, you know, as I work with students, as I work on design projects, you know, we chunk our project into 1 or more diagnosis cycles, then 1 or more design cycles, maybe needing another diagnosis cycle, then implementation cycle and an intervention of that implementation. So again, the idea of rapid cycles that constitute an overall project implementation or project process. Okay, so you know, it's important to have this type of process under control, to plan for it, but then understand the emergent behaviors that are going to come about from, you know, your execution of your research. And then reflecting on your process, I had part of an editorial in, again, our MISQ journal a couple of years ago. And this is a little bit philosophical, but as I was trained as a researcher myself, I had the great opportunity to work with an IBM fellow, Harlan Mills, and as he thought through his very deep understanding of software development, software engineering, he always said, understand intellectual control. You need to have intellectual control of your problem space and your solution space at all times to be successful. To me, that second bullet is very important in that extensive search for applicable theory on which to ground and predict behavior is unlikely to be fruitful in complex system environments. So I would argue it's better for a design team to begin immediately cycles of building and refining real-world artifacts in controlled ways, like we just discussed, and then reflecting and deciding, okay, how do I move forward with this project? Because you'll need to deal with a lot of emergent behavior, realizing you haven't completely understood the problem yet, going back, coming up with a better model of the problem, maybe setting different goals for what it means to have a good solution. So, you know, we need to reflect and keep our minds open as we capture this idea of intellectual control of our research process. Which leads to, and this is a little bit repetitive, but what are your contributions of your research project? And again, we said there are two basic contributions. There's a practice contribution and there's a theory contribution. And our theoretical contribution and our practice contribution can come at one of these three levels: the actual implementation, the growing nascent design theory, or a well-developed understanding and generalization of our mid-range design theories. And as we think about that, we ground our understanding of what is knowledge into two types, and that is descriptive knowledge that said this is how the world works, and this is the basic type of science, you know, physics, biology, chemistry. You know, we observe, we classify real-world phenomenon, we make sense of it, we build laws, we build theories. But a different type of knowledge is prescriptive knowledge, where we build, design artifacts to improve the world. And as we do that, we grow design theory, which I would classify as prescriptive knowledge. So as we think about how our projects both consume, use existing knowledge, and produce new knowledge, we had a paper that appeared in our DESRIS conference a couple years ago. We currently have a journal paper under review, but this is the way we sort of view that. I mean, here is our project at the top: problem space, solution space, evaluations. But we draw knowledge from descriptive knowledge and two types of prescriptive knowledge. That is the actual entity, design entities themselves that exist in the real world, but also our design knowledge, our design theory that we're building. Now, let me say that different disciplines have labeled this type of knowledge very differently. Some people call them technology rules, design principles, knowledge for action, but the concept here is that we're growing an understanding of how real-world entities and artifacts are used and applied, both in terms of human behavior as well as technology behaviors. So there's a lot to think about here in this slide, but let me move on. And like I say, if you're interested, I can, you know, talk to you offline and later. So people talk about impact, and you know, as we produce knowledge contributions, practice contributions, we want to make both practical impacts and research impacts. And the 2018 paper, the Baskerville et al. Paper, talks about and addresses some of these ideas of what are the impacts that we're making with our research. The final challenge is we don't want to be just one-off projects. We want to recognize that our project sort of stands on the shoulders of what has come before, and we want to be able to provide usable, reusable knowledge for future projects. And thinking about that in and of itself is a challenge. You know, how do we reuse existing design knowledge? How do we produce design knowledge that is reusable? So a recent editorial with, again, some excellent colleagues that appeared in a journal of AIS recently talks about that, and you know, how do we capture this idea of accumulation of knowledge? And our idea here is that there are essentially, each project will produce a chunk of knowledge, and over time we engage in knowledge journeys. And we want to map those journeys in sort of a three-dimensional mapping. Projectability or generalization in the problem space, fitness of our solution in the solution space, and confidence that we have in how well we've done the evaluation. So in this paper, we didn't try to get definitive scales here. We just said low, high, and medium. And we sort of mapped this on, you'll see a two-dimensional picture, but each of those balls is where we have the level of confidence or the level of rigor of our evaluation. Again, without doing a really extensive discussion here, but you can see this is a knowledge journey over time. So we may start at a very specific project level analysis. So that's projectability. We may just look at one very well defined and bounded goal, say maybe just performance. So maybe we've designed some sort of algorithm for a very specific project, and we just want to measure the performance as a measure of goodness of our solution. So low projectability, low fitness, but we do a great job in rigorously evaluating performance. So maybe our next part of the project is extending this to say 10 organizations in our scope. So now we've increased projectability, but we're still just looking at performance. And over those 10, say, project sites, our rigor may go down a little bit in terms of our evaluation because each of the sites is different in some way. And then maybe we'll extend not just performance, but maybe let's measure security, usability. So we're increasing fitness, but maybe now we're just back at one site again. And so you see where I'm going with this. Again, increasing fitness, maybe also increasing projectability, and then maybe being very general, going to a high level of generalization. Now maybe all of accounting or all of education can use our design theory, but now maybe, again, we're decreasing some of the fitness of what we're doing by generalizing. So as we think about this, you can say, on that two-dimensional space, or maybe even on the three-dimensional space, there are a number of movements we make as we progress our thinking in a research project. And we've just labeled them, some of them here, and we discussed them in the paper. Generalization, abstraction, amplification, contextualization, and but you can see there's other movements, and all of them could be appropriate, for the next stage of your research project. And here's just a quick definition of those four movements. So, okay, well, let me wrap up a little bit. I'm going to mention just maybe three more challenges, just with one slide apiece, because I know, you're all doing very interesting and different, diverse research projects. Collaboration is a challenge. How do you bring together a team with diverse skill sets, diverse ways of thinking, maybe diverse values, and how do you design a good research with this idea of collaboration and perhaps collaborative emergence of a design based upon the different contributions on your team. Next is, how do we interact with the whole field of, if you will, data analytics? I think there's some real synergies here, and you can see Shirley, Gregor, and I have done a little bit of thinking along this line. We presented a paper at a workshop at the International Conference of Information Systems a couple of years ago. But as we do good data analytic research, we're developing artifacts. We're developing data artifacts along the way. We're creating models, causal models. So how do we apply the good ideas of design science research into the processes of doing big data analytics and data analytics here. Some thinking to be done there. And the final, I know this conference has innovation in its name, so I would definitely like to challenge you to think about how, say, digital innovation and DSR work together. Again, Shirley Greger and I have done some thinking, just had a recent paper appear in the Information and Management Journal. How do we build on sort of the rich synergy between design and digital innovation? A recent paper in our field has discussed this sort of research gap that the world field of digital innovation has not really engaged very well the ideas of design science research. So we make a start in this paper to show how some of the two fields can come together. So let me wrap it up and see if we have any questions, but the key takeaways is, I think design science research really provides a solid foundation for thinking about how to do design, how to build complex socio-technical systems for many, many disciplines and fields, okay? Let me say that I'm organizing our Design Science Research Conference. It's going to be June 1 through 3 here in St. Petersburg, Florida. It's a beautiful place. It's I would encourage you to think about attending. It's just DESRIST2022.org. I'm sorry, 2022.org. But we're going to be talking about transdisciplinary research and how design science works in transdisciplinary research projects. But I hope today that I've challenged you in a number of ways to think about doing good design science research in terms of these challenges and to make an impact in the real world. And as a final thought, I think this quote from Helen Keller is just very appropriate for all of us to think about. So let me stop there. I can stop sharing the screen and address whatever questions. And, I know you've got a great river cruise coming up. I'm sure you're going to enjoy that. But happy to stay around and answer some questions for you.
Okay, Professor, we'll pass. I think you also can see in the chat box, you have the questions regarding the stakeholders. Do you prefer to read it yourself, or do you want me to give you the quotation?
Yeah, let me read it really quickly. I think we have a lot to contribute to the thinking about what AI-based systems are all about. And I actually have done some thinking along this line. Happy to communicate, but one of the challenges, I think, is the human-machine interface. How do we design that interface? In terms of AI functionality, is that in the machine totally, or how do we build that interface to support the best design of human interaction and human behavior in the use of that AI? And the question points out explainable AI. Well, if most of the calculations and functionality is in the machine, and if it isn't apparent, if it isn't obvious and not explainable, I would argue we need to move that interface more toward the human and let the human interact with a more explainable and understandable level of decision making. So I think the challenge is, where do you move the interface between the human behavior that we're designing and the machine behavior that we're designing in terms of AI? So it's an open question, but a very good question.
Okay, Professor, on my side, it's not a question. I took note here. One of the important points is collaboration. I was interested to know what the model itself presents within the complexity, and when you have stakeholders with, you have the cumulative knowledge, but when the cumulative knowledge, the knowledge accumulated by the team is to extend to put it on paper or try to map it on a model, how can you link this binomial between cumulative knowledge and collaboration and still have a good design model?
Very definitely. I think that's a very important question. I think as we build our research teams, our collaborative teams, we need to take advantage of everybody's strengths, and all of them have different knowledge bases. So the ability for the team to come together and to model the problem is, I think, where the essence of collaboration is all about. Because unless the team can agree on the problem, the goals that you're trying to achieve, and your research process has to be part of that collaboration. So all of the challenges I've talked about, I think, come together in this idea of how do you build a collaborative team and a collaborative research process. So I think there's a lot of research to be done in that area.
Thank you, Professor. That was a question. I don't know if anyone in the audience wants to place a question. If you want, so you can go to the last microphone and do it directly. If not, to not overpush the time of the professor, I can take written notes and then fast forward to him, and then I'm sure that he will send a reply back. Professor Evner, from the 𝗖𝗃𝘃𝗁𝗍 side and my personal side, and the team that organized the conference, and okay, then you have some comments in the box for you, some congratulations there. But from the 𝗖𝗃𝘃𝗁𝗍 management team, I'd like to extend again our gratitude for having you here. Indeed, for me, it was interesting to see that your original idea and there's movement there. So from 2014 until 18 and now, I'm starting to see evolution. You have not stopped. I'm interested in your new model. I'm happy about it, to be frankly, but that's my personal side. And I'll be happy to send you some additional questions to some research I have that will probably fit better to your new or most recent model. I don't know if you want.
Good. And like I said, my email is there. Please feel free to contact me if you want some of the papers that have been referenced in the slides, and feel free to distribute my slides to the audience.
I will, Professor. Once again, thank you. Gentlemen, thank you.
Thank you. Enjoy.
Guests on Zoom, thank you for your time. We're going to do now the coffee break, and then we're going to close the sessions for today. We start again back tomorrow morning, 9 a.m. sharp. So see you again tomorrow. Thank you for your presence. Bye-bye to all. Caros colegas, temos o coffee break lá em cima. Quem quiser o coffee break, we have the coffee break upstairs. We have nearly about, I would say, half an hour. The bus will be on the front of the hotel to pick us up to the Ribeira side. So we have around 5:30.